180. Hey darts fans, it's Timo Newman here, the transporter. Welcome to another voyage with the good ship Undarted Waters. I've got a good series coming up here for you, probably 5 episodes, and maybe even I can try and do it on consecutive days. We'll see how it goes, but I've got all kind of crazy new setup here, so I have no idea. But this is going to be really cool. I hope you enjoy it. It's got a combination of psychology, of physics, a little bit of maths, lots of darts, and it's called The Secrets of the Dartboard. And this is what happens when a physicist is playing darts for a few months and starts looking at this bloomin' board and thinking, how much bigger is the 25 ring to the bullseye? Or, how much bigger is the double segment to a treble segment? And I started asking all these questions about a year ago. And I thought, you know what, I've just got to measure all these segments. But you know what, that's not the right way to do it. If you want to know the relative sizes of all these little pieces of the dartboard, you have to switch on. That's what I finally did after messing around. And I realized there is a very simple way to get all of those measurements using just a straight ruler. Can you believe it? You can use a straight ruler and get everything that you'd ever want to know about the dartboard, and that's what I'm going to show you in these videos. But it's not really just about that, because once we have these measurements we can ask so many questions, and what we're going to do is discover what I call nuggets, like golden nuggets. These are numbers that may be known out there, but I don't know if most dart players know these numbers. I didn't know them, but they give you a whole new perspective on the dartboard, and they tell you the reality of the dartboard. But the reality of the dartboard is not what we see because of optical illusion, and it's not what we think because of the psychology of playing darts. When we are nervous or when we are frustrated, our unconscious or our subconscious does not help us to understand things in the same way that our conscious vision looks at them. And both of those are different to the reality, which we can find out using a bloomin' ruler and get everything from that dartboard. So this first video is really just a bit of motivation and to just show you how we can get these measurements and to explain to you why a ruler can give you everything you want to know. And then tomorrow we're going to start looking at the first 2 nuggets. So I'm very excited about this. It'll be a bit of a slow burn today, but I'm hoping that you'll really enjoy this series. I also need to introduce you to a friend of mine who's sitting inside my computer actually. He's a virtual friend. His name is Tony. But Tony is a blindfold player. He's not blind, but he's blindfold. And Tony just throws darts at the dartboard at random. So his chance of hitting anything depends on how big that thing is. But he's going to be our guide for a lot of this. Because what's going to turn out from all of this is that we can work out what Tony will get with darts throwing at the dartboard. You know, what's the chance of Tony getting a ton? What's the chance of Tony getting a double or a 180 or even 3 bulls? We can work all of that out, and I'm going to tell you, Tony's going to teach us some very disturbing things about our own game and how even if we think we're a pretty good player, turns out we're not going to be that much better than Tony. Alright, so Tony's going to have a lot of laughs here at the expense of us poor dart players. But we probably won't meet Tony for a couple of videos. In the short term, though, let me put these darts down and explain to you how can we get all this information. So my very first question I had back I think it was last August or September, I thought to myself, I have all this trouble getting doubles, but they're bigger than the trebles, obviously, because they're further out from the center. But how much bigger are they? And I then realized after a little bit of thought how you can work that out beautifully and very, very accurately without any bits of string or a compass or anything like that. So here's how we do it, folks. What we first of all realize is we don't have to look at individual segments, okay? What we can think of is that the area of a double or an area of a treble can be gotten from the area of the double ring divided by 20, and the area of a treble is the area of the treble ring divided by 20. The area of the big number here is the area of this middle ring here divided by 20. So we don't have to look at individual segments at all. We can always look at circles. Here's a couple of circles, a couple of plates that I borrowed from the kitchen. I've got some strange looks when I took these just now, but if you have a big circle and a smaller circle and you put one inside the other, I didn't practice this beforehand, I should have done. I mustn't drop these, I'll get in terrible trouble. But you see how there's an outer ring, the difference between the big plate and the small plate. But we can calculate the area of that ring. All we've got to do is calculate the area of the big plate, take away from it the area of the small plate, and what's left is the area of this ring. So this is actually not too bad, right? So to calculate the area of, let's just say, the double ring, to calculate the area of the double ring, we just need to know the area of the circle, which has a radius of the outer wire, and we subtracted that from the area of a circle with a radius of the inner wire, okay? And that will give us the area of this ring. If we divide that by 20, we get the area of a double. Perfect. Okay, now I'm not actually interested in the area of a double in squared millimeters or anything like that. What I want to know is, what's the area of a double compared to, say, the treble? Or what's an area of a double compared to, say, the big number? I always want to be comparing areas, so I don't care about what units I use, and I just need to know one fact, which is that the area of a circle is proportional to the square of its diameter, okay? So if I measured the diameter of a circle with my ruler and square that, that will give me a measure of the area of the circle up to some constant, which I don't care about, but then I can do that for all the different circles I'm interested in, okay? So let me just put this chart up now, and this will be helpful. You can tell this is all the first time here with this setup. It's all crazy stuff going on here. Right. So, first of all, before I start making measurements, I want to just establish some terminology. So this is like a bit of science we're doing here, actually. So we're actually doing science at this point. I had a question, how much bigger is a double than a treble? That's the reality, and we're doing this science where this question is going to lead to all kinds of interesting things. But when you do science, you have to be very precise with your language. So I want to make sure that we all agree on the words that I'm going to use. So before I say anything else, let's just agree on the language. So I'm going to say that one piece of the pizza of a dartboard, so what we might call a number, you can imagine this is 1 or 5 on the dartboard. I'm going to call that a segment. And then the parts of the segment, I'm going to give them these names: a double, the big single, the treble, and the small single. Okay, because sometimes the word segment is used for one of these regions, but that gets really ambiguous then. So this is my segment. These are the names I'm giving to the different parts, and then we've got the 25 and we've got the bullseye. Okay, so those are the names I'm always going to use when I'm talking about this. Okay. And what I'm interested in are all the relative sizes of this. I want to know how big is a bull compared to a treble? How big is the 25 compared to a double? I'm always comparing these things. And what I'm saying is, in order to get that information, all I need to know is the diameter of these different circles. The diameter of the bull, the diameter of the 25, the diameter from one inner treble wire to the other, the diameter of this circle from an outer treble wire to the other. Same with the inner and outer double wires. I just need to know those diameters, and I can get everything, and I'll show you that in the next video. And we will be able to work out all of the relative sizes of these, and all of a sudden, just out of that question comes actually tons of information, what I call these nuggets. Okay, so this is the ruler I used. You can do this on your own dartboard. I've got a Winmore Blade 6 dartboard. I just measured it with this ruler. I could have got the dimensions probably online, but who trusts all that, right? I want to know what my dartboard's doing. I've got a ruler. I can do this. I'm no fool. Well, I'm a fool, but I've got a ruler, so I can measure stuff. And let me write down then all these diameters that I got. Maybe you can measure yours and compare. And you can even follow along if you like over these videos and work out all this stuff alongside me as we go through this. There's basically no maths, okay? The only thing we need to know is that the area of a circle is proportional to the square of its diameter. That's all we need to know. We get everything we need from that one thing. Right, big reveal. Here's my table. I need these diameters. What's the diameter from the outer double wire to the outer double wire? I measured that in millimeters. I measured it as 340. And I tried to measure these to the nearest half millimeter, okay? And then the inner, so from the inner wire of the double to the opposite one, okay? So from this line to its opposite number on the other side of the board, I measured that as 319.5 millimeters. So I'm always trying to do it to the nearest half millimeter. And then the outer treble wire to its opposite number on the other side of the board, 214.5 millimeters. The inner treble was 194. And then the diameter of the 25 I measured as 32.5 millimeters, and the diameter of the bullseye I measured. Right, so those are my measurements, okay? So that's my data. So I'm a scientist, I've just measured some data. And this gives you, I want to give you like an insight into how science works, because I did science in universities for 30 years as a physicist and a biophysicist. I was a theorist. I never really did experiments, but I took data from experimentalists all the time and then tried to build theories to predict what's going on in future experiments and to understand what they were finding, okay? So data is crucial in science. If you do science with no data, you're not really doing science. You're doing something else, like philosophy, okay? You need data because science is about coming up with ideas about the world around us and then testing them. If you don't test them, it's philosophy or something else. Maybe bullshit, I don't know. But science, you've got to test those ideas with data. And if your ideas are shown to be incorrect, you've learned something. If they're shown to be correct with that data, it doesn't mean that they're true, but it means that you've learned something and you can maybe test them with some better data in the future, okay? But a beautiful thing about science is that it's like a rabbit hole. You ask one question and you get led down this rabbit hole, and all of a sudden you're discovering stuff that you had no idea that you were going to find out. And that's exactly what happened with this. Sometimes in science we try to solve a practical problem and we learn something fundamental about the universe. Other times we try to understand something fundamental about the universe and we actually discover something that helps with a practical problem. It's absolutely both ways. And it's kind of the same with this, that I started out just asking these questions, but we're going to find out a lot about the psychology of the game actually. Particularly, I mean, there are some nuggets that are coming up. I think one of my favorite nuggets is the ratio of a double to a treble is a really interesting number. And that tells us a lot about the psychology of the game, because when you know that number, which you'll know maybe tomorrow or the day after, I don't know, you're going to say, wow, why do professional players miss doubles so much? And it's all about psychology. It's all about the fact that the mind does not see the world as the world really is. So, as I said right at the start, there's like 3 layers to this. There's the world as it really is, which is like a ruler and measuring stuff, and that's the world as it really is, okay? Then there's the world as we see it with our eyes consciously, but that's not the same because we know there are optical illusions. We see things differently. It's very hard for us, it's very hard for us with our with our eyeballs to kind of, we can't compare the size of a 25 to say a double. It's too difficult because the 25 is in a circle. So there's what we see, and that's like a representation of the world, but that's not the same as the world. And then what's even worse is when we play darts and we're in the zone and we're playing, we're not even that conscious. It's actually partially our unconscious is operating, our muscle memory. And then when we get nervous, the conscious is like intruding on that muscle memory, on that unconscious, and kind of screwing it up. So you've got two like world views, none of which is correct, like battling it out. And then you've just got the reality, the dartboard is just laughing at us all the time, at us puny humans, because we get nervous and we screw up, okay? So the whole point of this series of videos, I think, is to at least give you the facts, like this is what the dartboard really is. And then you can compare that to how you see it, and then you can compare it to how you feel it when you're playing darts, particularly when you're nervous. And what I'm hoping is, this is kind of the point of this series, is that because part of your mind will now know the reality of the dartboard, that when your conscious visual brain is fighting with your subconscious when you're nervous, another part, a little quiet voice in your brain that knows the facts, can say, hey, guys, excuse me, this is what it really is. That double's actually much bigger than you think it is. Relax. And hopefully the reality that the science gives us can quell the turmoil in our minds and make us even better players than we already are, particularly if we're going through that crazy Matthew Edgar series. So I'm going to leave it there for today. Thank you for your patience. Not much darts today, but this is all about darts, and we're going to learn a lot of cool stuff, and we also get to meet Tony as well, which is going to be very exciting. So until then, 3 darts on the Oki, make them count, all the best, and thanks for your support. See you next time.